Yeah, so it'll also be able to do it for you. Our Python comparison operators. Then we also have numerical operators. So if you want to do addition, subtraction, it's just as you would do it on paper. If you do multiplication, you put so this symbol in between, and then division is just 3 divided by 5. If you want to raise something to a power, you just put 2 stars in between the 2 numbers, 2 asterisks, and that will raise 5 to the 2nd power. And then, as I sort of demonstrated before, you also do square roots and logs if you import the math functions. And so you can be able to take the square root of something, or you can take the log of something, for example. So any other questions up to this point? Okay. Okay, so next one, defining variables. So you'll be doing a lot of definition of variables, and what happens here is they're going to assign variable a value. So for example, if you type in x equals 5, it's always going to assign 5 to the variable, and so every time you put in x, it's going to output the number 5. We can assign 5 divided by 3 to x. So that's how that works. So if you get this this line here, c is equal to b raised to the 8th power. What does that equal? So you guess someone can just shout it out. 36. Yep. And then so d is equal to c minus 5.
31.
So that would be 31. And then what happens if you do y equals alpha plus 5? Do you have a question, or? I saw your hand go up.
Will it be apple 5 because 5 is converted to string?
Yeah. Yeah, so this is going to give you an error. So it's just a trick question there.
Okay, so it doesn't automatically convert 5 to
Yeah, unless you said alpha is equal to something. Well,
wait, so will that error out, or will you get the string apple 5?
I think it's going to error out. So if we go back to this thing here. And I keep getting, keep switching between escape and my control. So if you do, apple plus 5, it's going to say, yeah, you have an error. We can't, put a string with a 5. So that's just something we can't do. So basically, you can't really add different, you can only do numbers unless you assign a variable something, then you can add them together. Okay. So are you guys following along so far, or is this moving too fast, too slow? I just want to take a pulse here. Are we good? Oh, go ahead. You have a question?
I'm wondering if you can speak in general sense how Python is different from the other programming languages.
Yeah, so Python, so I know Python and I know R. I think so everything that I've shown you here, you can actually do in R as well. I think it's, for me personally, when I get into doing data science, sometimes R's packages for doing data science work is easier to work with. So for example, sometimes I need to calculate something called like the variance inflation factor, which tries to see how correlated variables are with each other. So within Python, I think there is a pre-packaged function to do it for you, but I prefer just to write my own lines of code to code that functionality out. Whereas R, you can just summon a package, called like variance inflation factor that will actually calculate it for you automatically without me having to write each line of code to do it. So I think so some functionalities are just easier to work with. R has very well developed data science packages, and for me, I think it just comes down to a preference. I haven't run into projects where I have to use one thing versus another. Any other questions? Okay. So the next part we'll go into lists. So basically, list allows you to store a list of values. You can think of it as a grocery list. So for example, if I have, A is equal to these numbers, I can assign it to a variable called A. So I can assign it, then I can ask it to print it, and it's gonna going to output this and say A is equal to this. And then I'm sorry, I'm gonna move this forward just a little bit. This is blocking out the scroller. Okay. So that's basically a list. It can store any kind of values, so it can store strings like this. You can say B is equal to these letters. It can store a bunch of booleans, so it can do that. It can also just contain a variety of values. So then, for me personally, usually I work with lists of numbers, in terms of doing calculations. So that's where, so this kind of list is the one that I often see. So you can add things to lists as well by using the append function. So if you type a.append number 10, that's gonna add a number 10 to the end here. So if we try that, and then the next line, you ask it what is A. So you can see that it puts a number 10 to the very end. And then you can also
question. Can we append a value of a different type? What happens when when you do a series of this, if you have our original A and then you append string B on it?
Yeah, so it'll be able to do that. Yeah, so just keep adding stuff. So if I initialize another line, I do a.append, letter B. Let me just. So it's gonna. Well, I did it twice. So here, yeah.
So you can have a list with elements of different types.
Mm-hmm. Right. So the list can contain. It doesn't have to be the same type within the list. It can be any type in there. And then you can also have a list within a list. So I can also say, a.append. I'm going to add a sublist there. And then if I ask it, what is A now? So it just adds, so out of 2 letter B's now adds a list within itself. So you can see the list that I just added over here.
So how would that compare to a list if you just had those elements 11, 12, and 13 in it? Because it looks like a sublist.
Right.
So how would that compare to just a list without that, like a sublist notation?
So I think it really depends on what you want to do with the list. So for example, if you're gonna do something to each element of the list itself, if you do like +5, I want to add 5 to each element of the list. Then so that's possible to do for the first 6 numbers. And the next 2 are strings, so you can do that. But if once you get to the end, you say I want to add 5 to 11, 12, 13, it's going to be confused because it's going to say, I can't add a number 5 with something that's different, that's a list. So that's really the difference. So that's how sublists will look like if we add it.
Question.
Mm-hmm.
What if you start over and write A equal 30 different series of numbers?
Mm-hmm.
Is it going to overwrite the previous A, or what's gonna happen?
Yeah, so if I say A is equal to, 4, 5, it's gonna say, oh, A is now 4 or 5. So you completely lost the other thing once you assign A to something else after you did the initial assignment. If you want to keep it, then you will have to say, but you want to assign A to something else and keep the original list that you assigned to A. Then I would say you will have to assign A to some other variable. So if I, started with A equals 4 or 5, I want to keep this 4 or 5 list, but I want to make A something else, then you have to say, B is equal to I think you have to actually so now A will be equal to 10, 11, 12. But if I remember, Python might actually do something different here with this. So what happens with B? Yes, okay, so B is original. So B will keep the original 4 or 5 value, and A moves on to be something else.
So, as you can see that it overrides if you have the same variable. Say we had a lot of variables, we have defined somewhere on the top, and then as we are humans, we always forget, and then we have forgotten. Is there a way we cannot override our variables? Say for example, I have A somewhere. I want to remember that I don't want to override it. Then what should I do?
I don't think there's a way, like a hard and fast way of preventing yourself from overriding it. Usually, I think if you do have lots of variables, you have to somehow keep track of it in your own mind. But usually there's not a way, to lock it down and say prevent myself from overriding stuff. I think that's, that's something that happens to me often when I'm programming. Like I forget that I want to keep something, and so I'm always have to do this thing where I, if I want to make sure I don't change something, I have to assign it to a different variable, and then just keep changing the original one. So yeah. Okay. So we just went through how to add something to the list. There's another way of adding to the list, so-called extend. And the difference between extend and append is that here, append, if I add this sublist, it's going to treat the sublist as one thing. I'll add it to the entire list. But if I do extend, and I want to add C, A, and B, it's going to add the elements of C, A, B separately to the list. To demonstrate that, so if I want to do b.extend, I want to add some more values to it. Then I want to see what is b now. So it's going to add the 6, 7, 8 separately. To the list, it's going to be 3 additional items it's adding versus the sub list of 6, 7, 8 as one item. So this list has 5 elements to it versus if you did b.append, this list, it only has 3 elements to it, 2 numbers in the list. And then you can also add something at a specific place in the list. So append and extend is always going to add to the end of the list. But if you want to add somewhere in the middle of the list, then you can do insert. So here, you could do a.insert. The number at the position 5 is going to, I want to add a string called extra thing. At the position 5, then you can do insert here. So if I want to do b.insert. And you'll see that.
So it is one based, it's not 0 based, right? The index.
Yeah, it's 0 based. Yeah, I was gonna get to that in a moment. So here you'll see that. So I said, add extra thing at position 4. Python starts counting things at number 0. So this is the 0th item. Then 1, 2, 3, 4, 5.
Okay.
Mm-hmm.
Okay, so it is insert as 4th, not insert after the 4th.
Yeah, it's inserting at position 4,
okay,
which is really the 5th element of the list. I'm going to insert at position 4 a string that's called extra thing. So here you can see I have position 4, which is the 5th thing in the list here. And then in terms of removing things, if you always want to remove the last value, then you can just do whatever the name of the list is. Let's say the list is C, you can do c.pop. It will just remove the last thing automatically for you. So if I want to remove number 8 from this list V, I can do b.pop. Then we'll print B. And now B is going to be equal to 4, 5, 6, some extra thing without the number 8. Yeah.
Can I assign it directly into a variable?
This list here, or?
No, the last. Let's say C equals B op. Will it take the last element of list B and put it into variables? Can I do an assignment?
Oh, we can try that. Oops. That's another project I'm working on, so don't get too caught up in that. But so if I do a.b.pop, then
What you say? Yeah.
because B was extra thing, so it took out the last thing here, and assigned to A. So the answer is yes. So then if you want to remove a specific thing from the list, then you can just put whatever it is and then remove it. So if I want to, so B now is just 4, 5, 6, 7. If I want to remove 6 specifically, then I can just do b.remove 7. Oh, hold on. So let me just assign b equals 4, 5, 6. So I do b.remove 6 is what we said. And then I want to print b. So b is now going to be 4, 5, and 7. That's how you take away things. Yep.
If the list has multiple instances of some element, will remove the first instance or all instances?
It's a good question. Well, we could just try it and see what happens. So if I have, lots of 5s, so if I do b.remove 5, and then let's see what happens to b. So I think I just removed the first instance of 5 that it sees here. So you had to keep going and going until you get all the 5s here. Then, is there another question?
It's kind of related. What if you know that you want your does remove also like what if you want to remove, say, whatever the 6th element was from that? Would you use remove for that, or is that a different function?
I think so. I think you had indexed the list. So we'll get into indexing in a moment.
Okay.
But I wonder if
opposite of the insert function.
So I wonder what happens if you do this. Well, so yeah, so I don't think you can do it quite that way. So I think, yeah, you gotta specify like a specific element that you want to remove here.
There are only 5 elements, right? Probably your 6 tells that it is out of the ring, there are only 5. Right?
Oh, that's true.
Oh, or,
That is true.
okay, so like remove the third element or whatever.
I think you use pop with the index.
The pop with the index.
Yeah.
So if you pop, let's say B is 2. So I think so 0, 1, 2. I think that's the second 5 there. So what's B right now? 6, 5. I think you just ignore what we put there. It just popped out the last element in there. So I don't think Yeah, so I think with the rule you have to like put this is the thing that you want to take out. And there is probably a function to remove these by the position. Generally, so I don't keep all these on the top of my mind. I just use Google and look for the specific function. Okay, so that's lists in terms of adding and taking away stuff. And then indexing, which is what we're getting to, where we think about the position of something in the list. So as I mentioned, the position starts with the number 0. So this is the 0th element. So 1, 2, 3, 4. That's how the indexing works. So you also index from the end of the list. So if you say I want the negative first element, then let's say I want the last thing here, so which is number 9. You can also put like -2, -3, so just start counting from the very last digit of the list and keep going backwards. So once you have the indexing down, you can also slice the lists in different ways, so just get different parts of the list. So for example, if I want to start from the second element of this list, and then I want to get to the second before last. So we know that for A, we start with, so the second element starts with number 1, and then 1, 2, 3. Just stop here. So if I demonstrate this in the Jupyter notebook. So I think actually, so I should mention it actually goes from, it'll stop before you get to number 3. So yeah.
So the argument start with position, first argument, and before position, second
Yeah,
argument.
before the position. So if I actually wanted to go to, if I want to, these 3 things, then I would have to go from 1, 2, 3, and I had to put in 4 here. And then so then you can get the 3 different things. And then so similarly, if you want to get everything for the last value, so then you say, I'm not going to put anything here. You just say it's going to get everything until the 4th position. So then if you do it this way, so it's going to get the first 4, and then it's going to stop right before it gets to position 4 here. And then similarly, if you want to get everything, starting with the second value, I think I reversed it here. If you want to get everything starting with the second value, so let's see what happens here. Yeah, so you start with number 1, the second position here, and then you go to 5, 6, 7, 9, and get everything to the end. And then if you just want everything in the list, then you can put the column there, but then for me that's just usually kind of redundant.
Curious, why does it exist? Why wouldn't I just call A?
Yeah, so I would say that's just generally
the last piece.
Yeah, so for me, I just do A, but if for whatever reason you need to do it, it's possible also. Yeah. But like sometimes you might see this somewhere, and in case you're wondering, what is that? It's just saying I'm getting everything in the list. Okay, so that's indexing and slicing. Any questions on this part? Okay. So other useful functions with lists, you can find out how many things are in the list by typing len, whatever the list name is, put into parentheses. So if I do, len A, it's going to tell me there's 5 things in that list. If I want to know if something is in the list, I can just put, blank in list. It'll tell me true or false, is this item in the list? So if I'm not sure if I have the number 17 in the list, I can do, 17 in A. It's going to tell me it's false, it's not there. And if I want to figure out where something is in the list, then I just type list.index, whatever is the thing that I want to find in the list itself. So if I don't know where my number 9 is in this list, I can do, so a.index 9. So tell me the index of 9, it's going to say, oh, it's number 4. And then here's also another way that you can extend a list is simply that you can just add things like this, but make sure you put things in the brackets for defining the list. So if I put A, B plus C, D, it's going to give me this one big list here. I just put the things together. And then some other special functions around lists that I use often. So one is range, and then you can put in what a number here is, and what this will output to you is it'll output a list starting from 0. It'll increment by 1 till this number that you put in here. So if I put in 5 here, it starts with 0. It'll add 1 to each item until it gets to 4, and then it stops. So if I were to put in range 10, it's going to give me a list that goes from 0 to 9. It just adds 1, increments by 1. And then if you want to find the length of this, usually you can just do length range 5. It'll tell you there's 5 items. And you'll know beforehand what the length is, but I'm introducing this concept right now because when you do loops later on, that's something that I very often use. So that's lists. And then sublists we touched upon, so we can put a sublists here. So if here A actually has 3 sublists inside. So if I define a list like this, and I say, then I ask Python what is in A. Oops. I guess. So I wonder if it just doesn't like my parentheses here.
With a different type of parentheses?
Yes, it wants a different type
Is it
of
just affecting the
parentheses.
like syntax highlighting, or is it?
I think when I put in the other those marks there, it doesn't recognize it as parentheses. I mean, as the quotation marks. Yeah. So it doesn't realize that this is a string that I'm putting in.
So you have showed us list, right? So I was just wondering to know where in your data science part you use list. Like, in your experience, what
Mhm.
would you tell us?
So sometimes when I'm making loops, I'm doing lists of things. So sometimes I create an output, I want to store it somewhere. So I have to use a list. So let's see, this is an actual project I'm just working on. So if you know the website called Kaggle, they have a lot of data science competitions. So I'm just like working through stuff there. But I'm wondering if there's one part where this is not quite a list, but I'm doing a bunch of calculations. I need somewhere to store my output. So I'm basically saying for each of these things, do these calculations over here, and then store in the list because I want to see what that list of calculations is that I created in the end. So that's an example where I'm doing multiple calculations. I need to have a way of accessing the results at the very end of it. So that's a simple example there. But so here, just going back to sublist a little bit. So here, if you put len A, it's going to say, there's actually just 3 items here. So there's 3 sublists. And if I want to know here with the indexing, if I want to index, this part, for example, I want to get at 5. I can do A, so the 0th index, and the first item here. So it's going to tell me, okay, that's 5. So basically A0 refers to the first sublist here. And then within this first sublist, there's 0 and then there's 1. So I tell it to give me the output that's at the 1st position. Output's 5 right here. So you can do sort of, so you can imagine if you have lots and lots of sublists, which is, you won't use very often, but you just keep indexing it down and drill down like that. Okay, so I think that's enough on lists. The next thing is dictionaries. So for me, I think I use this more often. So dictionaries, it's a way of having a key and assigning a value to it. So this is like the label of the value that you put in. So here you can say, I went shopping today. I bought 5 apples, 4 oranges, and 6 strawberries. So dictionaries gives you a way of labeling the value that you have in there. So typically we call this the key, and this is the value. So that's just a key value pair. If you want to add something to your dictionary, like, I bought 7 bananas also, I add that to my dictionary, you can just say A bracket bananas equals 7. And then when you print A again, it's going to give you this dictionary with the bananas added onto the end.
So can you add, I'm sorry.
Yeah, go ahead.
Can you add duplicates also into this, let's say, banana 7 once again? Could you add that? Does it allow you to do that? Key value pairs, you have the same key value pair repeatedly.
I think you have to keep it unique, but we could try to see what happens if you try to add something that's duplicate. So I think it's gonna keep my quotations again. But let me. Okay, so let me just change that around. We'll just shorten this a bit, so I do less typing here. Okay, so that's your dictionary. If I want to add like another orange to it, so if I add So I want to say oranges equals 20. So I think it's gonna just make reassign the value of orange. So when you print A again, it's gonna completely get rid of the it just added. Or actually it's because I added the S here, right? Let's say I think if you did the exact same thing, A orange equals 30. So yeah, so here it's gonna just replace that 4 with the latest value that you assign it to.
So apple is a key and 5 is a value?
Yeah.
Or the other way?
It's so
So
apple is the key.
key value, key value, key.
Yeah, so key value pair. So you can think of go ahead.
So only you can change the value, can't change the keys or you change the keys.
I think I don't think you can really change the key without taking the thing out and then just putting it back with a new key name. So yes, I think it's pretty fixed there. And yeah, so the way, and just to help with the key value pair part, you think of this as the key because when I want to see how many apples I bought, I have to put in the key and it'll return me that specific value. So that's how you can take the key value pair.
How do I return it? If I want to return value of apple. So
Yeah.
A.
So if you do A apple, oops. Yeah, so it'll tell you, okay, so that's fine. And that's why we call that a key, because it'll tell you whatever information is associated with that. And then here you can also do, like sublists, you can also do subdictionaries if you really want to. Sometimes I do this if I, calculate a specific, look at a specific variable with an equation, like calculating 2 different values at the same time. I might just decide to, okay, I want to keep track of these values in a subdictionary. So this would be variable 1. I want to know what is the first calculation doing, what is the value of the second calculation doing. Just keep doing it like that. So you can also have subdictionaries like this. So if you want to know, how many apples did we buy? I think I gotta change the quotes again.
You gotta just do like a find and replace in your PowerPoint and just swap all the quotes for.
That's true. I wonder if can I do?
Probably just.
Do you know the right quotes on PowerPoint?
I've actually never done it in PowerPoint, but I mentioned there's like a find and replace like tool. Yep, up on the top under editing, kind of you see drawing like shape effects. Yeah. So you can replace. So I pull those like both types of quotes and just replace them with like.
Yeah, I don't know if let me try to copy this. Oops.
Make sure you have the wrong type of quote selected. Okay.
So
then do the other one as well. Oh no, is that both?
I think I did everything.
Okay.
So I think that works now. Okay, thank you. Okay, so if I can make that faster. So I want to do a apple. I want to see how many apples I bought. Say okay, it's 5. So it's basically give me the value of apple, first part right here, which is the subdictionary right here. And then within subdictionary, I want to know the number of apples I bought. So
can you also use indices to address a certain part of this dictionary, or can you only use this keys?
Keys. What was the other
can I say I want the first element, or do I always have to use this key?
I think with dictionaries, you'd always be using the keys.
So can't say I want
reference
1
it.
to 2 or something? Can't do it?
Yeah, I don't think you can do it very easily. You'll see what happens if you were to do that. Maybe it can. Yeah, so here it's basically saying we can't do this indexing right here. You can Google around to see if there is a way of doing it, but usually I'm used to using the key and value if I'm working with a dictionary, and then with the list, that's when I do the indexing part. Mm-hmm. So you can do a similar thing with the other 2 questions. And then so we also have if-else statements. And I know that we're at time, so if anybody needs to go, feel free to. I think I'm just gonna go through these other items as far as I can get with them. So the next one is just if-else statements. If you want to, so basically it's looking at conditions. If something is true, then you want something to happen. If something else is true, maybe something else needs to happen. So this is just a very simple script. My friend gathers some data on me to see if I'm going to play tennis with him. So my friend knows that if the weather is sunny, then I'm going to play tennis. If the weather is cloudy, maybe the variable is just maybe. And everything else, I'm not going to play tennis. So this is a very simple example of an else statement. And you can see, within specific calculations I might do sometimes within data science. I'm thinking about what kinds of variables to incorporate within my models. So sometimes if I'm seeing how much variables correlate, for example, I might say if these variables correlate by this much, you can keep the data, but if else, if the variables have a high correlation among them, I don't want to put them in the model. So in that case, take that variable out, so drop it from the data set. So I guess that's an example of where I use if-else statements within my modeling work. Now the next part are loops. So as we want to perform a consistent set of actions across a list of items. So a very, very simple loop is, for everything in the list, let's say, I want to output that thing in the list. So for example, let's say my list is equal to, let me put a comma there. And let's say, you're doing a lot of other stuff, you forget what's in your list, and then you say, okay, I want to see what's in my list now. So you can say, for each for X in this list here, I want to print X. So it's going to print every single thing in the list for you. So you always start with the word for, and then you can give this thing whatever name it is. So basically, this is the variable that I will assign to everything in the thing that you're going through. And then you can add in whatever, then here you can put whether it's a list or maybe a dictionary that you're going through. And you can just print the item here that you're looping through. So here, just printing just going one by one through the list and prints everything in that list. That's a very simple loop here. So similarly, another example is if you want to increment everything in the list. So in this case, Oops. Oh, so let me. So here I'm just going through everything in the list. I want to add a number 3 to everything in that list. So if I want to see what the list looks like now, so before the list was 4, 5, 6, 7, and then right now you see that the number 3 has been added to every item in the list, 7, 8, 9, 10. And then just to break this down a little bit, so what I've been doing here is, within this part, what I'm doing is, first I find a length of the list. So we have 4 items here. So this length list is going to evaluate to 4. And then I do a range 4. So then what this part is going to look like is it's going to create a list 0, 1, 2, 3. And then I'm saying for every item in 0, 1, 2, 3, list 0 is equal to list position 0 plus 3. Then we go to 1, list position 1 is equal to list 1 plus 3. Then we go to number 2, list position number 2 is equal to list position number 2 for the old list plus 3, and so on and so forth. And that's how you increment through the list that way. I think similarly, you can also, this is a more complicated way of implementing, but
Are you passing 1 or 2 values to the range function?
it's just one item to the range function. So basically, len list here, it gives me the list. So what happens is, to break it down, so first what happens is I get the length of the list originally, which was number 4.
Right.
So then what this function here becomes is, now it's saying, okay, give me range 4. So range 4, that's going to be equal to 0, 1, 2, 3.
Yeah, so the default
Yeah.
function is 0 when you go to the phone.
Yeah. So then it's saying for xing, 0, 1, 2, 3. List s is equal to so it's basically, start with, so this range lunge list, it transforms to this. Then saying, so what this loop is really going through is saying, start with 0. My first element of this original list is going to be equal to whatever it was originally there, plus 3. Then I'm going to go to number 1 here. List index 1 is equal to list index 1 for original list, plus 3. And then I'm going to go to number 2, and then go to position number 3, and then do the same thing. And eventually, the list that I get is everything plus 3. So now it added another 3 to what I have here, and it's 10, 11, 12, 13.
Yeah, so what if you write list plus 3? So the same like this.
You mean like if I do this, if I do list is equal to list plus 3, so I don't think, I think you have to go to matrix functionalities.
In R, it's like that, right? List plus 3, it does 3 to every element.
I don't remember, but I think there's, I worked with an Octave before, just going through a Coursera class, and there's a functionality where you can do that, just plus 3. But yeah, here it's it's thinking. I think you had to do some sort of matrix conversion before you can do that operator. Okay, so that's how So that's how this part works. And that's why I bring up the range len list, because sometimes you have to go by the index of something. This range len combination is a way of iterating through the index of the list as opposed to iterating through each item of the list. But there is another way to do this, without using the range, is just simply going through everything in the list itself. I can also make it super simple and say for everything in this list, let me think about it. Yeah, I think if I do that, I don't have a way of saying, this for this particular thing in the list, add 3 to it, and that's why I do the range len option. So does this make sense to you guys? Or okay. All right, so that's looping. So this first type of loop is called for loops. You always start with the word for, and then just go through each item in the list or dictionary. And that's another kind of loop that you might often use is the while loop. So the while loop is saying, keep doing something till a certain condition has been met. So a simple while loop that we have here is, like I say, let's start with the variable x. X is going to start at 0. We're going to keep adding 3 to x until x is no longer less than or equal to 50. So if I do the while loop here, and let me get rid of these. So we see that x is starting with 0, and then if you keep adding 3 to it, and say, okay, what is x now? And say, okay, it's 51. So when x is 49, I added 1 last 3, then it became 51, and then when I came back here, is x less than or equal to 50? It says no, so I stopped the loop here. But this is if you don't have a set list of things to go through, but you want to keep doing something until a condition has been met, you would use the while loop. So that's everything with loops. If you guys want to practice, there are just like some problems where you practice if you want to get out your laptop and just do things on your own. I think, so I'll display this slide later when I get through functions, and we can do some practice as well. So the last topic we just want to cover for today is just defining functions within Python. So functions, it's basically when you write a function, you can allow it to take in a value, do something to it, and then output a specific output here. So some examples of simple functions. So in terms of syntax, you always start with def, so define, def, whatever is the name of your function. And then you put in what are the inputs that are needed for this function to work. Then you write your body of code, whatever needs to happen in the middle, and then you can return the final output. So if I write this function here, so going back to that example where we were iterating, so here I just wrote a for loop, but I can put that in a function as well. So if I want to do that, let's say, I want to run a function where it adds a certain thing to the list. So that's my function. It's saying add to list. Whoever the user is gonna put in a specific list they want. They're gonna specify what is the number they want to add to each item in the list. And then the function is gonna run a for loop. It's saying for each item in this list, that item is gonna be, so we're gonna add the number, for example, 3 to each item in the list. And output that list at the end. So then just as a comment, this notation is the same thing as saying list is equal to list. So list is equal to list plus n. So this notation here is the same thing as writing this. So sometimes when I want to type less, I just use this notation here. So if I write a function like that, and I'm gonna put this function to use. So now I say I have a list that's equal to 4, 5, 6, 7. If I use the function, I'm gonna say list, I'm gonna give it this list I just defined. I'm gonna say I want to add 10 to everything in the list. So it's gonna output a list that adds 10 to everything in this list. So that's how the function works. And also you can store the output of the function within a variable. So sometimes you do something to, let's say this input that you put in here, and then I want to assign to a variable so I can keep doing other operations on the same variable. And then I can do, v is equal to the output of add to list. This list I feed it. And then v it'll say is 24, so I just want to add another 10 to that list. And so you can store the output function that way. So, okay, so that's pretty much I have for today. So that's basically all the topics we want to cover. If you want to stick around, there's also, we can do some practice together if you want. So that's it. Thank you very much, everybody.
All right. Thank you so much, ladies and gentlemen. Was this helpful to you?
Yes.
Yeah? Very good. Well, let's thank Hannah for the wonderful class. And I have been sending the sign-up sheet. Did everyone sign your... Okay, cool. That's awesome. So this is the first time we are starting this class. This is our pilot program, and it was very well received. In a couple of days, we had 70 signups. We were shocked. So we will keep doing this, and this is our first time, and we want to keep on improvising it. Now, can someone give, since we didn't give a feedback form, can someone give us some feedback of how do you think this can be improved? Anybody? Any volunteers? Go ahead.
Maybe some real-world applications or concepts to review.
Okay.
Show how they can be applied in like a programming environment where you're actually writing something.
Sure.
Yeah, like data science specific examples.
Okay, examples. Okay.
Or for healthcare. It'd be great if we had like an example problem, like we're trying to figure out, like whatever, I don't know, like maybe a specific like patient population, and then work through learning some of the steps relative to that problem.
Okay.
Great. I missed one gentleman right there. Go ahead. Go ahead.
It would be helpful to have a syllabus or at least a brief outline of the topics covered in the description.
Okay, sounds good. Someone, go ahead.
Yeah, same thing, but I was like, maybe it was mentioned at the beginning. It would be helpful to have an outline before coming to class so that people can read up on it. And afterwards, I know maybe proprietary to you, but are you going to post PDFs of slides?
Yeah, we can definitely post these slides for you guys to look through.
Yes, one important thing is we are trying to build a developer community, and as part of building our developer community, we're starting to host these classes. We will be hosting a lot of classes like this. Now, we want to stay engaged with you and add as much value as possible and stay in connection with you after the class. Now, I want to ask you a poll. Do you guys prefer Slack or Google Groups to stay in contact? What's people in favor of Slack? Can you raise your hand? Okay, people in favor of Google Groups, raise your hand.
I'm glad we didn't put it in Google, right?
All right, we'll go with Slack, and I was trying to mess with Slack yesterday, and it's asking me for your email, so I'll put all these emails into Slack, and you should receive access to Slack. Okay, and also I wanted to talk to you about. Can you bring up our Meetup page, please? Meetup page.
Sure. Let me
see
it here.
So we are trying to host two kinds of events. The first is everything is patient related. Okay.
Let me
sure.
connect to the internet.
Okay. I'll just take a couple of minutes of your time and then we'll adjourn. Just want to make sure that we can stay in contact with you, and so that you can keep coming back and keep learning what you learned today and implement that in real world. So yeah, so just click here, Health Innovators. So basically these are all our events. So scroll down. So we just finished this. Can you go to calendar here? Calendar, let's go to calendar and show people what are all the events. Okay, scroll down. All right, so Monday we teach people on how to start a startup. So it's a lecture kind of series where Dr. Mohan will be teaching. And Tuesday right now it's for job seekers. And Wednesday we'll be teaching how to build a Facebook chatbot in less than 30 minutes. And Thursday we have healthcare brainstorming and innovation, brainstorming and networking. So if you want to talk about your ideas and get feedback from the community members, so you can come to these events. This is one of our popular events as well. And we probably will get rid of, what we are trying to do is we were running hackerspace events from 10 to 4, but the showing rate is kind of low. And what we want to do is we want to change the Saturday to an academy session where we will be teaching classes. So Mohan is going to talk a little bit about what kind of other classes he's going to talk about. This was an introductory class, and Hannah and I met a couple of on one of the Thursday meetings, and we just decided to host the class in 5 minutes.
So what we'll do is expand on this, or build on this, specific to data science, Python and the other non-Python related stuff for the data science applications. So this will build on this and take it to the next stage. So we'll be offering courses, couple of courses in that regard. And we also have courses in other areas, AI, predictive analysis, and also with respect to healthcare, we're talking about the patients-related healthcare activities. So we'll be building more towards that as technology comes. We also will be offering design courses, so people know how to do design if they are into IoT or micro level, Raspberry Pi programming, things like that. We'll be adding more and more to that. Okay. I want to ask you a question. How many of you?
Mohan, you can come here.
Yeah. How many of you would like courses in Saturday, Sunday versus weekdays? If it's a weekday, how many people will show?
Depending on the time.
Yeah.
Depending on the time.
Typically after 6:30 to 8:39. That range.
I mean, if these guys, if they show up on a weekend, it means that they
weekend is weather for most of you guys? Okay, that's a difference.
So I have two more questions for you guys. So one is, how do you guys feel about the pace for today? Was it too fast, too slow?
Good.
It was good? Okay. And then my second question is, like, how much background do you guys have within data science and statistical modeling? Because I was thinking about, should I bring more context, or would the data science part actually make it more confusing? So that's why I just decided to stick with, bare Python for now without providing too much context yet. But how much do you guys know, like, modeling work?
All very classic different levels.
Okay, but you guys, like, who has not touched modeling at all? So, okay. So I think it'll have to be a blend of, like, programming and also just a basic modeling.
Probably split into two.
Yeah, because otherwise, like, I think as we go on, the coding would start to get lost because, like, usually, yeah. So I think we would want to do modeling before coding if people don't have too much experience with the modeling part, because then, they would have context.
Yeah, observation. So I coded there.
Okay.
I've been planning to learn to pick up Python for a long time. So basically, for me, it's just picking up or translating the differences between Perl and Python, right?
Okay.
But if I had never coded before in my life, then I think I would have had some troubles.
Okay.
But maybe I don't imagine.
Okay.
Yeah.
So who has never coded before here? Is there anyone? Okay. Cool.
So we'll send you email on how to stay connected, and every Saturday we start at 10 a.m. here on the. We'll tell you we were usually our events were on the 4th floor, but since we're having a big turnout, we'll see which floor to hold on to. But we start at 10. So what we recommend is bring your computers next time. You can come to this building anytime after 10, and there's going to be a bunch of people practicing Python, and you can work with them. At the end of the day, we want you to build applications on Python and provide you all kinds of support. So we're looking to build a developer community, and I also want to point you out to one other event where we are trying to get, let me show you that. Can you open this, Patient Innovators? Yeah, right here. Right here. So we try to attract two kinds of people to our community. One is patients, because we want patients to be innovators. We want to innovate. We want patients to hack their own diseases and conditions because they know the best. And so our first event for patient innovation is on August 22nd, and it's going to be around diabetes. If someone you know has diabetes, please tell them to come here, because we want to know the problem statements. And then what we do is we get all the problem statements and we release it to you guys, the developers, so that you can work with the patients suffering from diseases and come up with superior solutions. And then we're going to make all of this open source so that other people can build upon it and make it better. That is the big plan. So first we need to start with the community, and then we'll hook you up with the opportunities to work on. Okay, so you can start coming here anytime after 10 next Saturday, and we'll see you there. So that's all I had. Is there any other questions we can answer? It was so great to spend a Saturday afternoon with you, and I hope to see you again.
Yeah, thank you so much.